All right, welcome everybody. Thanks for joining me. I did hear a little rumor earlier that the description for this was that you might be coming up and showing off your apps. If you were expecting that, not so much today. What did you guys think of the keynote this morning? Liked it? Yeah? Awesome. Cirque du Soleil thing? Cool? Yeah? All right, sweet. I'm going to be talking about how to take a web app and turn it into one of the new Chrome packaged applications using the new technologies that we've got available to us. Chrome packaged applications do a lot of things that are really cool and really allow us as developers to build applications using the technology that we know today already, that we know how to use, divs and CSS and all that great JavaScript stuff, and build applications that feel like they're installed, that actually let's have a look at, there we go, that break out of the browser, right? So that they don't have that browser bar across the top. They don't feel like that experience of, oh, I got to open the browser and then I got to go to this site. You click a button on the dock or you click something on the start menu and the application starts just as you'd expect it to. With an enhanced UI that allows us to really be able to do things that we can't normally do in web applications. I want to be able to open a window. I want to be able to move it around or resize it. I want to be able to do things that with web applications I can do today, but I might get blocked because I'm not allowed to open new pop-up windows and things like that. So an enhanced UI that really lets us get beyond what we're used to doing. Offline by default. Apps that just work, right? Today, when an app gets installed on your computer, you expect it to work. When an app gets installed on your phone, you start it, you expect it to work, whether you've got an internet connection or not. Chrome packaged applications should work like that. Web applications should work like that. And we need to get users thinking about that, right? Like, I got made fun of a little bit when I used this reference, so pardon me. But when my mom starts a web app, she goes to Gmail or wherever she's going. If her computer's not connected, she doesn't think that it's going to work if it's not connected to the internet. So for her, we need to really say, hey, these apps work offline, and Chrome packaged applications allow us to do that within this new model that we've now got. And my battery is dead. So I guess I'm going to have to move around. My name's Pete LePage. I'm a developer advocate on the Chrome team. And it's my job to help folks like you guys build web applications, build Chrome packaged applications, and really take advantage of all the cool stuff that you saw in the keynote this morning and be able to get better access to your customers, to your users, and all the fun stuff that Chrome really has to offer for you. You can find me on Plus. I'm also on Twitter, though I don't tweet very often, as well as my blog, and I've got some stuff up on GitHub. So when I think about sort of the legacy packaged app, right, this is what a legacy packaged app looks like. I've still got the address bar up at the top. I still need to start it in the same way. In fact, let's get out of here and let's have a look at a little packaged app. So we're going to take a look at this particular application. This is just a simple RSS reader that I've gone and built because I wanted to sort of see what it was like to build an application and then convert it to a packaged application. So you can see, like, I've got a list of different feeds available. I can scroll down, I can go click on one of these, but I still have the address bar up here. I can't open new windows. It's not exactly the best connection. It's not exactly the best experience that I really want to have as I'm reading through my RSS feeds and all of that. So I chose this application in particular because it does a couple of things really well. One, it's a single-page application. So it works really well. There's not a lot of navigation from page to page to page. It should work offline, right? Like, I should be able to take all of that data that I've got and all of the stuff that I'm used to using, and I should be able to just say, all right, great, I want to access all of that without having to do anything else. Oh, there we go. So we're going to walk through what I went through to get there. So let's go back to the slides for a sec, and try that again. There we go. That looks a little better. So when you think of a legacy packaged app, you had a manifest file. How many people have built a packaged app or a Chrome app in the past? All right, so a few people, about half the room. So you had a manifest file, and that manifest file was really what told Chrome how your app should work and what it should start, where it should go. And within that manifest, it's had effectively a linker. It said, hey, when you start, I want you to go open this index file. And that index file might go off and grab any resources it might need, any HTML or CSS. But all of that stuff fit into a package, into a zip file that you uploaded to the Chrome Web Store. And it could also sometimes have a background page. And you might use that background page to say, go pull for data so that you could pull data down and save it somewhere. You might use some context menus. But all of that stuff, you'd have to set up a loop. You'd have to either use a loop, you'd have to use set interval. There were a whole bunch of things that were, they would cause some pain in the butt sometimes, and could potentially, if you didn't write it very well or use some bad practices or worst practices, if such a thing exists, could affect the performance of Chrome for everything else. So one of the things that we really wanted to address as we started making this enhancements to Chrome packaged apps is how we do that. How we make it easier so that the applications that you're writing, it's harder to do the wrong thing. So let's get started and have a look at how I converted this. Now, I'm going to throw up this warning. I'm just going to say, time out for a sec. This is a developer preview, right? This is not something that you can go ship a production level app on. If you do, congratulations. You can't get it into the Chrome Web Store. But if you give it out to a bunch of users, it probably will break at some point in the future. All right? So just as that word of warning, as you're playing with this, if you're like, hey, this worked yesterday, but now that I got a Chrome update, it doesn't work, go have a look at the docs for known issues and any updates, because things are changing on a regular basis, and we're working to get a lot of new great stuff added. And sometimes that means taking your feedback and going, oh, guess we didn't think about that one too well. I guess we better change that. All right? So getting your feedback is really important to us. We want to hear what you have to say about these applications as you're building them. What are your experiences? How do we need to make these things better so that you can build the type of applications that you want to build? So with the new architecture, it changes a little bit. Remember before we had our manifest, which would then kick off an index file? In a new Chrome packaged application, instead of kicking off an index file, the first thing that the application does is it kicks off a background script. So that background script, thinking very similarly to if you were writing a native application for Windows or for Android or for any other device, there's some kind of like C# file, or there's some main file that's going to go. It might kick open other windows and all that kind of stuff. It works in the same way. So that background script is going to go, and it's going to start running first thing. And when you want to start the application, it then goes and opens your application UI window. So it says, oh, hey, the user wants to start. I guess I should open this window up. And it goes and opens that window. So the difference here, and the really important thing here, is that background script needs to listen for events. We'll talk about that in a sec. So the application that we used, we didn't use all of the technology that's possibly available to us, but we used a bunch. One, we used the Chrome Experimental Apps API. Maybe it's just standing too far away. Maybe if I go over here. We used the Chrome Storage Sync. I'm going to talk about each of these in depth in a little bit, but Chrome Storage Sync, how many people use Chrome Sync in Chrome when they use Chrome today? Like to sync all your passwords, your favorites, all that kind of stuff. And kind of cool. Chrome Storage Sync basically lets you take whatever you want for your application, within a set of limits, obviously, and store that stuff up in the cloud so that no matter which computer I'm logged into, I have all of those settings synced across all machines. So I can have, maybe my credentials, maybe a list of read items. All of that stuff I can keep synced in the cloud. Chrome Storage Local, which is very similar, but it only is local to that specific machine. We use Chrome Alerts to notify the user of a bunch of stuff. We use sandbox pages, and I'm going to talk about content security policy in a little bit and why we'd use a sandbox page. And we used AngularJS. We used AngularJS because Angular did something that made our lives a little bit easier. How many people have heard of content security policy? Yay, OK, only a couple of hands. We're going to go into more depth on this. This is something that's really important. But it's going to change the way we think about a lot of stuff. And it's, like I said, it's really important, and it will make the web a lot safer. Nice big eye chart. This is how the app is kind of laid out. So you can see right there in the center of the app, right, is that background page. And that background page goes and does all of the stuff we need to do. And I promise, we will get into like real code here shortly. I think it's like 1 slide or 2 slides away. So we've got that background page, and it goes off and kicks off the app page there at the very bottom. It goes over, and it gets access to data in different data places, all right? And it goes up to the cloud and asks for feeds. There we go. All right. So the first thing we need to do in our application is we need to update the manifest. The manifest for a new packaged app has changed a little bit. And I want to highlight a couple of the changes. So the first thing that changes is we need to add a manifest version 2. Manifest version 2 tells Chrome, hey, this is a new Chrome packaged app. It also turns on content security policy. All right? Second thing, we want to add offline true, because our apps are designed to work offline. Everything that we need for our application is sitting there in our zip file, in our package that we zipped up and uploaded, and is good to go. The next thing is we need to add the app background scripts. Right? If you remember before in V1 apps, that was where we put our index file. We said, hey, this is my index file. And then finally, we need to add a couple of specific permissions. We need to add the app window permission, which says, hey, we want to be able to open windows. We need to be able to manipulate windows. We want to do all that stuff. And then we need experimental. Now, we are only going to need experimental while we're in an experimental stage, right? So that will go away sometime in the future. And that right now is one of the things that will prevent your app from getting uploaded to the Chrome Web Store. All right? So if you go and you're like, hey, I got this great app and I want to get it in, and you're like, why won't it upload? Well, that's a big part of the reason. So let's go and actually do that. So I have here my text editor, and don't worry, we got some nice, decent-sized fonts here. And instead of doing it in there, I'm going to do it in my updated, and I'm going to go grab my manifest. All right, so we need to add a couple of things. So we need to add our manifest version. And we want to set that guy at 2, right? We want to add offline enabled. And we want to set that to true. Then, remember we said we had to change from the index to instead use our background page. So I'm going to say background, and I'm going to go here and say scripts, and turn that into an array, because we want that as we can have multiple background scripts. And I'm just going to say background.js, and I'm going to put that in my JS folder. All right. 2 other things we need to do. Add our or I guess it's just 1, permissions. And app window and experimental. All right. So we've done all the things we need to do here. All right. So we've got our manifest set to go. We can't actually go hit run yet because we don't have our background page. So let's have a look at what is in our background page. So in our background page, we're going to put primarily just one chunk of code for now, and that's the listen for the application start event. So instead of doing loops and all kinds of other stuff like we did before in the version, in the legacy packaged apps, everything is event-driven, event-based. So we want to say, right there in the top bit of our app, Chrome experimental app on launched, add listener. So we want to say, we want to listen for an event, and we then say, all right, when that event fires, we want to start and create a new window. And the window we want to create is the index.html. Now, I can also add a couple additional properties. So I can say, I want that window to open up at 1024 by 768. I want it to open at 100 pixels over and 100 pixels down, and type shell. All right, so let's actually, we're just going to cheat a little bit. We're going to copy this. And, new file, paste that guy in, background.js. So we've got our background page in, so it's there. Now, when the app starts, we're going to be good to go. There's a couple other events that we can listen for, like the onInstalled and an onSuspend event. We're not going to worry about those right now, because really the only thing we want to do right now when we start is the onStart. A couple of things we need to do just in preparation. In the future, we probably won't have to do this, all right? But for now, we do. This stuff is only available in Chrome Canary. There's a reason for that. Kind of fun, kind of, a little bit on the edge. Chrome Canary is where you can always get the latest and greatest. All right, it will be in Dev Channel soon. Now, the great thing about running it in Chrome Canary is that you can run Chrome Canary and Chrome Stable or Chrome Beta or Chrome Dev side by side. So that way, if you're ever like, OK, well, I want to go try something and see how it works, and I still need to actually be able to browse and do my real stuff, you can have those both side by side. So Chrome Canary. And then we need to just go add our app, just like we did with the legacy packaged app. So first thing let's go over to Chrome Canary. And I'm going to close this guy out. I'm going to go to Tools and Extensions. And so I've already checked the developer mode. So I'm going to go and load an unpacked extension. So I'm going to grab this, click Select. Aha! All right. Dictionary keys must be quoted. So line 16. You know that pink thing that's right there? Might have given it away when I was doing this early. Try that again. All right. So now, if I go over here, you'll notice I've got my legacy. We've got my final, so we'll see what that looks like in a sec, but I've got the updated. One thing you'll notice, the difference between the legacy and the updated, the legacy is kind of gray there because I don't have an internet connection right now. By putting that offline enabled there, it tells the app, hey, this app works offline. And as we go through and have a look at why it works offline, you'll get into this a little bit deeper. But let's go and start our app. OK. It started, but it doesn't look very good. I would expect to see some numbers there. I'd expect to see some data. Like, at least we have an app running. Our window opens. We've got a sad panda. We can deal with sad panda. All right, so let's see it in action. We already saw it. What happened there? We actually got hit by something called content security policy there. How many people have, I asked how many people have heard about content security policy. It's a new thing that's coming, and it's going to make the web a lot safer. But it also makes things a little bit different for us as developers because we have to approach things in a different way. I kind of like to use a little bit of an analogy of it and talk about it as when you go trick-or-treat, or when you take kids trick-or-treating at Halloween. You know, they go out to all these strangers' houses, and these strangers give them candy. And you get home, and as parents, the parents sort through the candy and say, you can have this, you can't have this, you can have this. As a kid, you're like, but I want all of it, it's all good, right? Like you want all that candy, but some of it's potentially dangerous. The web is very similar. When we say, hey, you can take anything you want, you might get good stuff, right? You might get great stuff, you might get great data feeds, you might get whatever you want. But somebody out there might be malicious and say, I'm going to give you some bad stuff. And you're going to get something like a cross-site scripting vulnerability. Well, content security policy basically says on the web, you are allowed to get content, data source, whatever, from these places, but not from these. So just like when your parents came in at Halloween and said, you can have this candy, but you can't have this, content security policy does that same thing. It says, this is safe, this is not. Now with Chrome packaged apps, we said, you know what? Let's make these apps as safe as we can. So we put a relatively strict set of rules on that. So let's talk about a couple of the things that are potentially dangerous, why we block them, and what's going on. So any code that comes from outside of your control, so that's not delivered in the package of your application, is going to be blocked. That means if you try and go get Google Analytics, the ga.js kind of code, that's going to be blocked. Now, sure, you get it from Google Analytics. We're probably not evil. At least I hope we're not. Well, we've got this thing that says don't be evil, right? So that's okay, but we don't know where you're going to go get all this stuff from. So we say if it's not in your package, you can't have it because you might go and get something from somebody else's source. Maybe somebody said, oh, hey, I'll host Google Analytics code for you, and all of a sudden it's not actually that code anymore and they're doing something malicious with it. So if it's code from outside of your control, you can't put it in the app. Second thing, we block inline scripts, including JavaScript URLs. That one kind of sucks, right? We're kind of used to sometimes doing that kind of stuff. Now, it's not exactly a best practice for doing that, but inline scripts, the problem with inline scripts is, so we're looking through this HTML, and we've come across a script block. Well, if we come across a script block, how do we know that you, as the developer, actually put that in there versus somebody injecting that in via some kind of cross-site scripting attack or something else? So anything that gets injected, it could get injected into the HTML. No, sorry, we're not going to let that happen because it could potentially allow that cross-site scripting. This one, I think, should be pretty obvious why we don't let you have eval, right? Like, eval is kind of evil. It's one letter away. So unsafe code execution like eval, because you could basically take any text, run it through eval, turn it into some nice, cool, nasty script, not so good. Pretty much every browser today supports JSON parse and JSON stringify. So realistically, the need for eval is pretty limited. There are a few places where eval is useful and where eval is good, but safe, good, protecting your users, protecting your customers, protecting your data, potentially evil. I usually like the safe, good better. So let's have a look at a practical example, like a very specific example here. So this is in the HTML of my application. I've got a function that says call me, and it prints out a little line. And I've got a button, and the button has an on-click directly on it that calls the function. And I've got some text in there, right? So that's not going to work, right? We've got both inline script block, or an inline script block, and we've got an inline script in our button as well. Not going to happen. So here's the better way to do it. Now, it's a couple more lines of code, but it's the better practice to do it. First thing we do, we've got our script that calls we've got a script block that links to our file. And then we put our button there that says, hey, call me. It's got an ID on the button so that we can get access to it a little bit later. And then we have our function in the JavaScript that says call me. And we add an event listener to say, hey, go grab that call me button and add a listen so that when the user clicks on it, maybe they call. Sorry, bad pun, bad joke. I like that song. I admit it. I'll go away in shame now. So this is the better way to do it. There's a bunch of really great content out there that talks about CSP. I've got a link to it at the end of the slides. It's really worth having a look at. Converting from inline script blocks and that kind of stuff, not an impossible thing to do. It takes a little bit of work and a little bit of rethinking on our part, but something really important that we should do. So one of the things I'm going to do, let's actually get out of here for a sec. And before we go over there, let's tab over here. So one of the reasons why I chose to use this app and why I chose to use Angular is Angular actually has some CSP built right, or CSP ability to deal with it right inside, so that I don't have to go and deal with all the craziness. I can actually just go ng CSP. And that now, if I did everything right, I'm going to close this guy, open this up, and I didn't do it right. All right. I'm going to cheat one sec. I'm going to have a look at my file over here, ng-csp. That was the right thing to do. Oh. Yeah, reloading helps. So over here, go reload my app. And sure enough, it doesn't work again. All right. I can come back to that because I've actually got something else I'm going to do in my next step here. All right. So one of the other things that is really important and really useful to do in moving your app to a packaged app is taking that shared and common functionality, pulling it out of your JavaScript places where you've got it in, where it's going to get used in multiple places, and putting it into the same place. So with the RSS reader application we've got, it goes up and it pulls for data, and then it pulls that down and it goes and puts it into a data store. So for something like this, we want to take that and put that into the background page so that we take all that shared code that's all over the place, maybe a little bit spaghetti-like, and try and really reduce some of the work that's going on. One of the ways that you can do that, and that's really useful, we'll dive into the Chrome storage API in a sec, but in my application, I can take this Chrome storage listener and I can say, hey, anytime anything changed, I want you to go listen for this, and I want to update all of the rest of the page so that, oh, hey, I just got new feeds. Let's go update what's displayed to the user. So I was talking a little bit about the package, making stuff work offline. And making applications work offline, we can do it on the web today, but it is a small pain in the bum, to put it mildly, right? Like, there's app cache, then you got to deal with, well, where are you going to put it? Are you going to put it in an IndexedDB? You going to put it in local storage? Are you going to put it, where are you going to put it? And, well, typically as web developers, we say, hey, let's go get data from the cloud and then display it on screen. Oh, well, maybe we should just store it locally too. So when you start to think about your applications and how they should work offline, we want to think about them in a little bit of a different way. So we've got our packaged app, and our packaged app should talk to a local data store first, right? So some kind of local data storage. That way, if I have no network connection, I'm always going to be able to pull data in. I start my app. Hey, look, there's data. It may be stale and old data, but at least I've got something, right? Like, you go to Google+, you go to any other site, you want to see something when the app starts, all right? Now, it'd be really kick butt if we could also store all of that data in the cloud so that it was synced across all of my computers, so that I didn't have to go, oh, hey, well, I haven't run this app in a while on this computer, so I guess I don't have this data. I want all this stuff synced across the cloud so that I open my Chromebook, great, I've got all that data. I open my iPad with Chrome on it. I've got all that data. I've got open whatever device I've got. I've got all of that stuff synced across the cloud. And there's a great new Chrome API that's going to help me do that. And then finally, from our local data store or from our background page, we want to go and have that talk to the back-end services for our application. Right? So our packaged app, our UI, is never talking to any kind of application server-side stuff. All of that is happening on a separate business layer. Right? When you think about, if you've taken computer science classes and you separate out, hey, here's my business layer, here's my display layer, here's all this stuff, you're separating all those out. And that's what we really want to see in these packaged apps. So that your app talks to the data store, pulls everything in there, and then the background page or any of those other pieces, then go and pull stuff in so that we can deal with those pieces. So we have this set of, actually, new set of Chrome storage APIs. They give you all the power of Google's Chrome sync stuff without having to go deal with, oh, well, I got to go set up a bunch of servers. I got to figure out how to do data syncing. I got to figure out how to do all these things. All right? Now, it's not meant for you to store tons and tons and tons of data. That's Google Drive. And we do have some easy abilities for you to get into that. They're not quite there yet. We're not going to talk about those in today's session. But to be able to store user settings, not necessarily login information, but application settings or little bits of data like key value pairs is exactly what we want to use this Chrome storage API. So there's a couple of things we need to do in order to use it. One, we need to turn on the storage permission, right? Because it needs a permission. And then there's two things we can do. We can get and we can save. Or I guess it's technically set. There are some other APIs, but these are the key things that I want to show you here, right? So if I want to save something, I use this set. Let me highlight this out here for a sec. And we send it an object. That object is just a name value pair or a JSON object. So I've got, hey, here's all of the Chromium articles that I've got that I want to save. And I'll give it that list of items. All right? And then I've got a callback that's used to say, all right, everything's saved, you're good to go, all hunky-dory. All right? To get that stuff out of the backside, we use the Chrome storage sync get. And we just ask for what we want, and we give it a callback again. And so Chrome says, OK, yep, you want that? Sure, no problem. I'll give that to you in a sec. Goes off, gets it, and pulls it down and gives it to you via that callback. All right? So let's actually go take a look at the code we've got. And trying to do the two things that I just talked about up on stage would have been a little messy, because it changes a lot of stuff in this application. So I want to show you the things that we did in order to get that to work. So our background page before, you remember, was just that start for our application. So we've gone and we've got that still in here. So we add our Chrome experimental app launched, right? And we open up our window. And we've moved a lot of the code that our application is using out into here. So we've got a factory here that's going to go and do our feed fetching. So all of our feed, my mind is blanking. All of our feed fetching, all of our feed syncing, all of that is done here in our background page. So we've got our factory to get our feeds. We've got a factory again here where we're refreshing things. And then we've got some Angular stuff as well down here, just sort of Angular filtering stuff. We've also gone and created a store module. So Angular allows you to have these concepts of modules. So we've got in here our store module. We create our factory, and we want to say, hey, we've got our state store and our content store. as we were working on this, we sort of said, okay, well, we're storing large amounts of data. How do we do that in a really good way? How do we take all of that information and put it in the user's hands without sending lots of data up to the cloud, right? Without overloading all the user's sync storage space and complexities. We said, okay, well, what if we separate out the blog feed, each RSS post or each RSS item from its state? So we said, we want to sync all of the state, whether it's been read or not, and whether it's been starred or not. We're going to store that up in the cloud, because that's, what, 2 bits? It's not even a byte for that matter, because it's just like a Boolean. And then we store all of the information about the feeds on the user's local computer, because we can always go get those later. Those are easy to get. So we've separated those 2 things in our data storage. And then when we go to actually get these things, just sort of scroll down here. Let me, so we go and get our feeds from content storage, which Angular then has a way to say, hey, if there's everything in there, we want to go and do a for each on each of them. So we're going to go and iterate through each item and go and add them to the user's display. All right? So let's go and add this guy. So I'm going to load our unpacked extension, and we'll grab number 3 that we've refactored. Nope. And sure enough, now we don't have anything, but that's OK right now, because I don't have us plugged into the network right yet. So now we've got all of our data, right? Like everything works right, but we're trying to pull everything from our local machine. We don't have anything. So let's try it again. I'm going to close the window. Actually, I'm going to join a network first. I'm going to be a little bit brave. I'm going to try it on wireless first. Think we can get it working today? All right. So close this window. Go. And so sure enough, now we've got our data. All right, so we've got everything in there, and I'm going to go turn Wi-Fi off again. So now, because I've turned the Wi-Fi off, if we try and go get everything from the server, it should work. Close this guy out. Start it again. Refactored. And sure enough, we have everything back again. Now, if I were to go and try this on another computer that I'm signed into, all of the things that I've read are going to be synced across the different computers. Now, it's going to have to go and pull that data down on the second computer. But the key point being, it knows what I've read, knows what I've starred, it knows what I like. So I'm able to store specific sets of information about what I'm really interested in or how I want to go and do these things across different places. All right. Keeping the application up to date is also really useful, right? It would be nice if, when I first started the app, it didn't have to go and download all the stuff and say, all right, that first time. But instead, it just always stayed up to date. So that the first time I started it or that first time I opened it after not using it for 2 days, all of my data's there, right? You go to Google+, wouldn't it be nice if that first time it loaded, it was all fresh data instead of going, oh, now I got to wait for it to load. OK, now I can see what I want. We want that ability so that when users start the application, right? Users want that fast. They want, there's something else, like a different app, that's just as good, but theirs is faster. They're going to go use the faster app. They're going to use somebody else's app. So we want to make sure your apps are nice and snappy. Your apps are nice and fast. So there's this new Chrome.alarms API, and it works very similarly to set timeout or set interval. It's got three. I guess it's got three. I thought it had four. It's got three different settings on it. One, delay. So you can say, hey, from the time you fire this event, I want you to wait 5 minutes and then fire. It's got a period, which is very similar to set interval, and it's going to fire every X minutes. And then finally, there's a when that's like for a specific time. Now, for alarms, to use that, again, we need to turn on a specific API or turn on a specific permission. So we're going to say, hey, we need that alarms permission. And then we go and create an alarm. We give it a name, and we give it a particular property. So whether we want it to fire in a period of minutes, whether we want to fire it in a delay or a when or whatever. So in this particular case, we're going to use a period in 5 minutes, all right, which is going to fire the event every 5 minutes. Now, remember one of the things that I said earlier was that it's really important that these apps really work seamlessly and not cause a lot of headache or anything like that. So we don't want to have functions that are sitting there looping. We want everything to be event-based. So because this is an event, we need to create an add event listener. So we're going to add our event listener. So I'm going to go, and I'm just going to, in fact, we'll pop this into our application. And I'm going to put this into not that background. And I'm just going to close a couple of these so that we can actually see where we are. All right. And I've put in a place where I want to put my background. So I'm going to say, I'm going to add my listener. And let's make that a little prettier. And the other thing we need to do is start our alarm. Now, I've already added the alarms permission, so we don't need to go add that. Pop that in. Now, the app will stay up to date, and everything will fire every 5 minutes. Now, I probably should have picked a blog feed that was posting more than every 5 minutes. We're probably posting once a day right now because of I/O. But you can imagine for something like this where you've got something that you want to keep up to date, maybe a friend's feed or maybe something from Twitter or any other API that's changing on a regular basis. You want that to fire much more quickly. All right. So there's a bunch of other new functionality in APIs that are available to us that are pretty slick. Some of them didn't really fit into the app all that well. Some of them showed up. So because of the way the app is written, they didn't really fit all that well. They were one of those things where it's like, okay, well, this wasn't really particularly needed. But I still thought they were really cool and definitely worth talking about. There we go. There's a new identity API that's available that allows you to have your application automatically log into Google services. So the user says, hey, I want to log into this particular Google service. This is really for making it easy so that you can get things up to Drive, right? Or if you want to access any of the other APIs that Google has to offer. So there's a couple of things that we need to do here in order to use it. First thing you need to do, add that identity API, identity permission, and then we create a new block within the manifest file, and we say OAuth 2, so it uses the OAuth 2 protocol, I guess it is. And we go in and we provide a client ID. So you get your client ID from the dev console. So code.google.com/APIs/console. You get your client ID from there. And then you specify the scopes that you want to get access to. Much like you do if you're writing any kind of other OAuth application or any other kind of web app that uses OAuth, we take all that complexity, all that pain in the butt. If you've ever done OAuth 2, it's definitely at least easier than OAuth 1, but it's still not exactly the most fun thing to do. and we simplify it for you all in here. So we'll ask the user to sign in. Yep, great, here you go. And then you don't ever have to worry about it again, because all those requests that you make will be done with the right set of permissions. And then there's also, when you need to go get the authentication token, there's just a simple API that you call and say, hey, go get me that token. All right, we're good to go. We can start doing things. One of the ways that I wanted to use this and see myself using this for in the future is if you wanted to build an offline RSS reader that actually grabs the user's feed from Google Reader, you could use exactly this API to say, all right, let's go authenticate the user. Now we can go and get their feed information, figure out what they're reading, and pull it in that way. So that way, instead of having to go deal with anything else, we're golden, right? Like we can just, sweet, don't have to write anything crazy in order to do that. There's a bunch of other stuff that I think is pretty slick. Context menus, right? Like real apps. If I've got an app that's installed on my computer, I expect to be able to right-click on it and pull up a context menu. Chrome apps have the ability to say, hey, I want a context menu. So through Chrome Context Menus Create, you can go and do that. All of these, don't worry about writing any of these down if you can't really read it all that well. You can go check the slides later or have a look at some of the docs. Create windows. So apps should be able to create as many windows as often as they want, right, without being spammy or annoying. But real apps can do that. We're kind of prevented from doing that on the web, for a good reason most of the time. But we just say, create a window, provide a URL. That URL is a local URL, right? We can't say, open a URL to HTTP whack whack Google or whack whack whatever. It has to be a file within our package. We've got great stuff for doing window manipulation. So I can go and set focus on a window. I can say, this window should be in focus right now. Or minimize and maximize windows. Just like you can with regular applications that the user has installed. They're used to having apps do that. Like, hey, this app, I want you to go away because I'm not really using you right now. Great, done. We can have them restore, move, and resize just like we can with regular installed applications. One of the ones that I think is kind of cool, text-to-speech, so you can have your apps start talking to you. There's even one that'll listen for what you say, so there's a speech recognition. Speech recognition, plus a little text-to-speech. You could start writing your own kind of fun. Anyways, you can figure it out where we're going on that one, or where I think you should go on that one. There we go. There's a couple other API changes that I want to call out because I think they're pretty important. Links. When we're used to writing web apps, we put links in our apps, right? Like, you've got a link that goes to here. You've got a link that goes to there. Links will open in a new Chrome window if they go to somewhere external, all right? So keep that in mind that, like, hey, if you put a link to http://google.com, it's going to go and open up a browser window. It's not going to open up within your application window, right? So links to outside places will open in a new window. By default, this one threw me when I first did it because I was like, why can't I select anything? I'm trying to select something. Right? Think about most applications that you have. You can't go and select most of the text on there unless it's a text box. So just like an installed application, you can't select the text in one of these applications unless you specifically say, this region, this block here, the CSS div span, whatever, is selectable. So by default, we say user select is none. We can't put iframes in there. We got to use something called the browser tag instead. Again, that's a security thing, right? Think about, hey, we've got this app, this great app, and we let you put an iframe in, or somebody, you're rendering content from somewhere else, and they put an iframe in. All of a sudden, you've just opened this gigantic potential security vulnerability because other people can start putting anything they want within your application. So we make it very explicit what you can and can't put into those. You can create some sandbox iframes, and these iframe, the browser tag is a sandbox thing. If you didn't make it to Eric and Mihai's session earlier, they showed some specific demos around that. Kind of neat stuff. Local storage and Web SQL are also turned off. Local storage is turned off primarily for performance reasons. It's synchronous, right? So, hey, go put something into the data storage. Okay, please wait while I do that. Right, like applications should be fast. Having synchronous things happening is not exactly going to do that. We've also turned off Web SQL. It is a deprecated API. Will it ever go away from the web? Probably not, but it's not getting the attention it deserves. So instead, use something like IndexedDB, which has a pretty strong following right now, and it's got a good browser support. The file system API is another great one. It allows you to store like big files on the user's file system in a sandboxed environment, so you can't exactly go read their resume and their user documents file or something like that. Or use the storage API that I talked about earlier, so that you can go in and say, hey, I want to store something on the user's computer. I want it synced up into the cloud, or maybe I just want it locally in this one specific place. Most plugins and a number of the Chrome extension things are disabled. So you can't go put, some kind of plugin in your app, right? We stop those from happening. We think the web can be built without any plugins. You saw this morning in the keynote, the Cirque du Soleil thing, there were no plugins there. That was all HTML, CSS, and a bunch of divs and some images. So all that stuff can be done without plugins. So let's start doing that. And finally, I know this is, I'm guilty of it myself sometime. You put in an alert or something like that so you can do debugging, modal dialogues. Users don't want modal dialogues. So instead, use custom lightboxes, use other things so that the app can keep running, right? Because the one key thing about modal dialogues is they're not just modal for what the user's doing, but they also stop the app from running, right? So any of the JavaScript is just sitting there going, doo-doo-doo-doo, we're not doing anything. I could stand up here for 3 minutes and not say anything, and it's just as boring, right? So you want to keep your app to keep running. So what's next? You can start using this and start playing with this today to really build apps that break out of the browser, right? I go back to those first 4 points. They break out of the browser so they don't have the address bar, so they don't look like a browser-based application. It takes that power that we think really the web has and really allows it to break out of there and become a much bigger platform. The enhanced UI, so that you can control how applications look, how they feel, how they open and close windows. They feel like they're installed, that they work offline by default. This is the one I think I'm most excited about because it means that I can write stuff that works offline and that people expect to work offline. I'm going to use it again, and some people will make fun of me. My mom doesn't expect web apps to work offline. She's going to expect these to work offline. So we gotta start building them this way. And finally, really takes advantage of the native capabilities through new APIs. I didn't get into it at all in this session, but you should drop by the Chrome booth afterwards. We actually have taken one of these new packaged apps, used the Bluetooth API through this packaged app, and we're controlling a Lego Mindstorm robot with it. So you've got access to Bluetooth, USB, TCP, UDP. You've got great access to truly the device that these applications are running on. But most importantly, you can start testing this today. Go install the Chrome Canary build and start playing, because there's a lot of great stuff there. There's a bunch of really good resources if you're looking to get started in this. The Chrome packaged apps documentation, the URL's there. These slides will go up online momentarily, but if you go to developers.google.com/Chrome, all of that stuff will be linked from there. If you've got questions, you're working on something and you're like, why isn't this working? Send an email to the Chromium Apps mailing list. We also have a whole bunch of great sample applications, so you can see how some of these applications were built. And finally, the last one that I put up on there because I thought it was really useful, Mike West, who's at the back of the room, wrote a wonderfully fantastic article that is an introduction to CSP. I gave you sort of a taste of it today, but he goes into a lot more depth, what it's additional things it's useful for, and if you're going to use it in a website, how you can go and adjust some of the different permissions to restrict or loosen things for websites. You can't change them in a Chrome packaged app, but you can change them on the web. With that, I want to say thank you guys very much for coming and sticking with me. I hope this was somewhat interesting for you. The link to the slides is up there. You can see it, goo.gl/5KRVB. The slides are up there now. I'll say thank you. I'll open it up to any of your questions.
So how would I put analytics into my app?
That's a great question. So I guess I don't need to repeat them because we have microphones. We are working on an analytics API that will allow you to go and do that so that you can just say, hey, here's my analytics UI or UA string, and here's the things I want to fire. We're not ready with it yet, but it will be coming at some point in the near future.
Could I copy the analytics.js files and package them?
So the question was, can I copy the analytics.js files and include them in your package? You could try. My guess is it probably won't work. I haven't tried it myself. It uses cookies, so the answer is no. There you go. Yeah?
Is this stuff going to work on Chrome for Android and iOS?
So Chrome for Android, Chrome for iOS, it's something we're definitely thinking about. I think as Sundar said this morning, it's something we want to bring there. It's not there today. I want it just as soon as you guys do, because, hey, if I can write an app and have it work everywhere, I'm a happy guy. So.
When can I write my Chrome app in Dart?
When can you write your Chrome app in Dart? I believe you can write your Chrome app in Dart today. Well, so I'll give you two answers. One, you can write it in Dart today, compile it down to JavaScript, done. You can publish today. In Dart, I'm not sure how close the Dartium browser is staying to the Chrome dev channel. So whenever those guys are close to whatever we have in dev today, is that.
Well, the manifest.json had like JavaScript function calls?
Yeah, so that's a good question. I don't have an answer to that. Do either of you guys know offhand? Okay, so right now JavaScript only, but it is something that potentially is coming. Yeah. Well, so Mihai is one of the developers, and like.
Hi, I'm one of the engineers on Chrome apps. These APIs, we have a language agnostic binding system, and the goal is to expose them to Dart, native client, and JavaScript. Right now, only the JavaScript part is implemented, but coming soon, those other two.
Cool. Any other questions? All right. Well, that's a way to finish. I'm sorry. I'm going to let you out a minute and 20 seconds early. I hope you don't mind. Thanks, guys. Have a great day. Have a great I.O.